All right, so good evening once again, students. So we are here finishing up coordinate geometry. Today we are going to be looking at parallel lines and perpendicular lines. Just to give you a recap of what you would have looked at before, we looked at, in the previous lesson, we were looking at how to find the equation of a line, given that we are either given the gradient on a point or 2 points or a graph line where we can find the y-intercept and we can calculate the gradient from the line using a construction of a right angle triangle and using the formula rise over run, where the rise is the y value over the x value. So that would be related to the triangle. Now, today we want to continue on that. So we're going to be looking at parallel lines first to begin with. Now, so when we're referring to lines, we also want to think of them in terms of their equations. So we know the equation of a straight line, the general form is y equal mx plus c. All right, so if we have two lines and they're parallel, what are the things that you would bear in mind about parallel lines? What are some of the things that come to your mind when you talk about parallel lines? You want to start us off, Mr. Lamar?
Yes, sir. Parallel lines,
Yes.
So they go in the same direction, but they never meet.
Right. So never meet in the sense that they never converge or they never diverge. They travel together, equidistant apart.
Yes,
all
sir.
right. Now, you can imagine that if you have two lines that are parallel and both of them have their own equation, what would you expect in terms of their gradient? What can you say about parallel lines?
I expect them to be the same.
Their gradients would be the same. All right, and that is expected because remember, when you measure the gradient, you're measuring the steepness of a line based on a slope. And if both of them are parallel, they're going to have the same slope. So it means that their gradient is going to be the same. All right, so that's one principle that you have to bear in mind. So two lines are parallel if their gradients are the same. And so just to give you a diagram to show what that looks like. Now, but in terms of their equation though, remember if you recall from the general form, we know that m is the gradient, but c would give you what again? What c would give you? Ms. Waysom, what c would be?
C is where it cuts the y-axis, sir.
Right.
Intercept.
So it would be the y-intercept. All right, Miss Green, these two lines, would they have the same y-intercepts?
No, sir.
No, because it means that they cut the y-axis at different points. So even though their gradients are the same, their y-intercepts would be different, right? But the fact that they are parallel, you can always bear in mind that they will have the same gradient. And so that bit of information, immediately you can use the gradient of one to determine the gradient of the other. All right, so that is one key thing. All right, so we use the same formula by constructing our right angle triangle. We will get the rise over run formula. So we know that M1, which is the gradient for the first line, is equal to M2, which is the gradient for the second line. All right, moving along. Now, looking at this question, it says to show that this straight line 2y plus 4x equal to 7, and the straight line 3y plus 6x equal to 2 are parallel. Now, how would you go about approaching this question? If you want to show that these two lines are parallel, what would you try to establish? Ms. Waysom.
Sir, looking at the layout, sir, would you find the LCM?
Well, we're not dealing with fractions here, so
No.
that would help you. Anything else?
Or grouping the terms.
All right, before you even get to that, based on what we said about parallel lines, what should come to your mind?
Sir, I'm not sure.
What did we say about the gradients of parallel lines?
They are the same.
They're the same. So it means that we need to establish that both equations have the same gradient. But we cannot establish that unless it is in the form y equal mx plus c. So are these equations in the form y equal mx plus c?
No, sir, no.
All right, Miss Green, how do you know when the equations are in the form y equal mx plus c? Mr. Lamar, you would like to assist us? Anybody?
Sir, no.
Okay. All right. So let me just go back to the previous slide so that you can look at it.
Sir,
Yes, go ahead, Lamar.
when a equation equal y equal mx plus c,
All right.
so wouldn't that be for like a straight line?
Yeah, well, yes, it is a straight line. These are also straight line too, but they are not written in that general form y equal mx plus c. Why do I say that?
Sure, I don't know.
Because if you go back to the general form, in that form, y has to be the subject. You notice?
Yes, sir.
Right, so it means that when you look at these two equations,
Oh, yes, sir. 7 would have been because of
would y be the subject in any of these?
no, sir.
No. So it means then in order for us to get them in the form y equal mx plus c, we have to rearrange them and write them in the form y equal mx plus c. So it takes a little bit of transposing, which unfortunately we'll be looking at next week. However, just to give you a general idea though, transposing is really similar to like when you're solving an equation. So if you are making y the subject, it means that everything else has to go on the other side of the equation. All right, so let us start off by looking at the first equation. So we have the equation 2y plus 4x equal to 7. And so we want to get it in the general form y equal mx plus c. So it means that this 4x we want to bring across on the other side. So we will have 2y will now equal to, when we move this 4x on the other side, it's going to be a negative 4x. And so we put it first because we want the form mx plus c. So here we would have plus 7 afterwards. All right, so next what we want to do is to get rid of the 2 from in front of the y. And if you're multiplying the y by 2, then it means that you would have to divide both sides by 2. So if we do that, divide this side by 2. Now each of these can be divided separately by 2. Right? It is the same as if you had actually divided the entire expression by 2, it would actually be the same thing. But just to give you the form, it would be in terms of y equal mx plus c, we want to divide each of these terms separately so that you can see the general form. So if we cancel this 2 out here with this 2, we're left with y on the left-hand side. We divide -4 by 2, we're going to be left with -2x for that first term. And then now, the last term, it's not completely divisible by 2. So you can leave it as an improper fraction, or if you want, you may leave it as a mixed number. And if you leave it as a mixed number, you'd say 2 into 7 goes 3 times, and remainder how much?
1, sir.
And then you put that 1 over 2. All right, so that would be in the general form now, y equal mx plus c. So this we would refer to as equation 1. All right, so next we want to write the next equation in the same form. So if we take the second equation, we would have 3y plus 6x equal to 2. And so we're going to do the same thing, bring the 6x on the right-hand side of the equation, and that will leave us with 3y on the left-hand side. So we'll write the 6x in front, so -6x plus 2. Now we divide both sides by 3 to get rid of the 3, just as we did with the 2 in the previous equation. Divide each term by 3. So this cancel, leaving y by itself on the left-hand side. And now -6 divided by 3 will give you -2. So you will get 2x here. And here for the last term c, we would leave it as 2/3. All right. So now both equations are in the form y equal mx plus c. Now, for the first equation, once we have this in the form y equal mx plus c, now the gradient for this equation would be the number beside the x. So the first equation, if we call that m1, the gradient is m1. M1 would be equal to -2. Now for the second equation in the form y equal mx plus c, the number beside the x is also the gradient. And so we can call that now m2, and that would be equal to -2. All right. So here we can say now, since Oh, sorry. Okay. So since M1 equal to M2, therefore, the lines are parallel. Any question, guys? Is it clear? So that is just something that you need to establish if they ask you to show that the lines are parallel. All right. And I'm just using these two lines with the arrows on it to mean parallel. All right. Now, so that is something that they can ask you to show that two lines are parallel, and this is how you go about doing that. Maybe as well, they could give you one line, the equation of one line, and they could tell you that there's a parallel line, and they give you a point for the parallel line. And now they may want you to find the equation of the other line. So in that case, all you would have to do, the given line or the given equation, you write it in the general form, y equal mx plus c, and then you identify the gradient from that. And with the point that you get for the other line, then you could find the equation, which is something that we have done last class, right? All right, so with that said, let me clear this and move on, guys. Any question before we move on? Is it clear to everyone? Raise your hand for me if you are clear on what we have just done. Mr. Lamar, how about you? All right. Ms. Cavero, is that clear to you?
Yes.
Okay, all right, moving on. All right, so as before, I said, if we write this in the form y equal mx plus c, this is what it would look like. Now, even though I had written the 2x after the 3, you have to remember that the gradient is always beside the x. So it's the coefficient of the x that gives you the gradient. And here, in a similar way, all right, there's an error here. This 3 that you have here should be, this 3 should be here. So the 3 is supposed to be here, guys. So don't take that to be there. So this would be actual -2 for the gradient. So this 3 should be here. All right, so we would conclude that the lines are parallel since they have the same gradients. All right, any question again? No. All right, moving on. All right, now with that said, we're going to talk about perpendicular line. Now, anybody know what are perpendicular lines? When we say two lines are perpendicular, what properties do these lines have? Ms. Waysome?
So they're going in the same direction?
No. Parallel lines are not going in the same direction. Anybody else want to make a guess? Yes, Mr. Lamar.
Sir, sir, 2 or more lines where, so we can call it vertex, make a right angle. To form a right angle.
All right, so I understand what you're saying about vertex. I would call it the point of intersection rather than vertex. We generally
Okay, sir.
vertex where two lines meet on a triangle, or for any polygon, wherever two lines meet on any polygon, we generally refer to it as a vertex.
Yes, sir.
So in this case, perpendicular lines, one would be at right angle to the other. All right.
Yes, sir.
And so where they intersect, they will form right angle. So two lines are perpendicular and so this is a property too in terms of their gradients. So two lines are perpendicular if the product of their gradients is -1, meaning that if you multiply the gradient of one of the line with the gradient of the other line, you will get a product equal to -1. So that is always true for perpendicular lines. All right. So just to illustrate what the perpendicular lines are. So these two lines would be perpendicular to each other because they cross at a junction and they're at right angle to each other. All right, so if we look now, M1 would be the gradient for the first line pointing northwards, and the second line, M2 would be the gradient for that pointing eastwards. All right, so here, if we find the gradient of that one, we get M1 equal to Y1 over X1. We find the gradient of the second one, we get M2 equal to Y2 over X2. All right, so what you realize is that one is the negative reciprocal of the other. Now, what do I mean by that? Now, if you have, let's say the gradient for this line, M1, let's say that this gradient was equal to 2. Then the gradient for the next line would be the negative reciprocal of 2. So how do you find the reciprocal of 2? Anybody?
2 times -1, sir.
Well, not exactly. So reciprocal, when we say we find the reciprocal of a number, we're talking about finding the inverse of the number, the multiplicative inverse. Anybody have any idea what that is? So the reciprocal.
Switch it around.
All right, so the reciprocal of a number then is just simply 1 over the number. So the reciprocal of 2 is a half. The reciprocal of, if you have a fraction and you're finding the reciprocal of it. So if you have 3 over 2 and you want to find the reciprocal of that, you would put 1 over it, but that would flip this upside down. So this now would become 2 over 3. That would give you the reciprocal, right? Is that clear, guys? Raise your hand if it is clear, guys. Okay, good. So going back to what I was saying here. So if M1 has a gradient of 2, then M2 should have a gradient which is the negative reciprocal of M1. So what would be the negative reciprocal of 2? Mr. Lam, all right, go ahead, Ms. Reza.
I was saying -1/2.
It would be -1/2. Or -1 over 2 if you want to think of it that way. All right. So what that means for parallel lines, sorry, not parallel lines, but for perpendicular lines, when the gradient of one, if you find the gradient of one to be a number, then the gradient of the other should be the negative reciprocal. And this would be not 1/3, but 1/2, negative 1/2. Now, so this is always true for gradients of perpendicular line. So now you can see that when we multiply the products of the two gradients, so if we multiply M1 times M2, then of course, we will have 2 times negative 1/2. And if we multiply these together, what would we get?
-1, sir.
-1, right? And so that's why this definition gives you it's really a property. It says that two lines are perpendicular if the products of their gradients equal to -1, right? So that's something that you have to bear in mind. Just as we know that two lines are parallel if their gradients are the same, we now know that two lines are perpendicular if when you multiply their gradients, you get -1. All right, so that's something that you have to know. All right, so with that said, is that clear to everybody? All right, going once, going twice. I want to clear this and move on. All right, so here we have a question. It says that here to show that the line y minus 3x equal to 2 and the line 3y plus x is equal to 10. Here to show that they are perpendicular. Now I'm going to ask you to try this question for me. And you're going to do it in a similar way as how we did with the parallel lines. We first have to write the equations in the y equal mx plus c form. And then we find their gradient. What is the gradient of M1? What is the gradient of M2? And then to establish that they're perpendicular, you multiply both gradients together and you should get -1. So go ahead and try that. I'm going to give you about maybe 3 minutes to do it. And then now we can move on. Just raise your hand when you're finished for me. Anybody work out the gradients yet? All right, you guys should be finished by now. Anybody finish? All right, let me just go ahead and do them in the interest of time. So for the first equation, y minus 3x equal to 2. If we are to make y the subject, so we have y minus 3x equal to 2. Now to make y the subject, we simply move this negative 3x. We move it across the equal sign, so it becomes a positive 3x. And now we'll have y equal to 3x plus 2. All right, and so this would be the first equation. So if you want to call it equation 1, all right, so the second one in the form of y equal mx plus c, we would have 3y plus x equal to 10. So first we want to move across the x. So we will have now 3y equal to negative x negative x plus 10. If we divide both sides by 3, each term you divide by 3. Then this cancel. So now we have y equal to, now negative x over 3 is the same as negative 1/3 times 3. Sorry, times x. Plus 10 over 3. Now, if you wish, you may convert that into a mixed fraction. What you get if you convert that into a mixed fraction? Anybody?
3 1/3, sir.
We have 3 1/3. Now, from the two equations now, from the first equation, we would say M1 equal to what?
3x, sir.
Not 3x, remember.
3, sorry.
Coefficient, so that would be just 3. And from the second equation, so this is equation 1, this is equation 2. And now we want M2.
-1, sir.
And that would be negative 1/3. And so we have M1. So you're going to say since M1 times M2 equal to 3 times negative 1/3 equal to negative 1. Therefore, the lines are perpendicular. So therefore, the lines, and if you want to write the line in terms of the equation, so therefore the lines y minus 3x equals 2 and 3y plus x equal to 10 are perpendicular. And I'm just going to write 2 lines at right angle to mean perpendicular. All right, guys. Everybody's good with this so far? Any question? Raise your hand if you're okay with this, guys, so I can move on.
You can do
Mr.
you can do
Lamar,
one more. So
what
can
are
you do
you-
one more? So can you do one more?
all right, I don't have many examples of this. I think this may be the last example on this, but just watch the video with the past papers and you will come across similar questions, right? So you just scroll down to one of the videos that have to do with coordinate geometry and just watch it, all right?
Yes, sir.
Okay. All right, so with that said, guys, so we see that the product of their gradients equal to the same, equal to -1. So they are perpendicular to each other. All right, so this is the end of coordinate geometry. Let me stop sharing this. All right, so I'm going to move on to our next topic. And our next topic here is functions and relations. Now, we looked at graph, we looked at coordinate geometry, and we noticed that these coordinate geometry and graph, they have